The high levels of pollution on our planet are generating a change in industrial activities. In order to counteract the negative effect produced by our current economic model, Ecotr Chile aims to enhance sustainable development of mining companies. Our company has thermolysis technology developed by one of its founding members, Javier Ruiz, owner of RGS2 Novagas, a thermolysis plant located in Spain. Our thermolysis process uses end-of-life tires from mining companies, known as OTR-Tyres, a residue hard to degrade as raw material that currently are stocked in landfills inside mining operations. Ecotr aims to be a solution for this environmental liability of the mining industry. Our company is aligned with the recycling goals in Chile that will come into force during 2022. In addition, this technology is able to convert up to 95% of these residues in commercial products, boost the circular economy, and reduce the carbon footprint. In this video, you will see the trial of the thermolysis recycling rubber plant of our OTR-Tyres for Ecotr. The operation was carried out at RGS2 plant during the first week of June 2020. This trial processed 3 batches of shredded rubber from OTR-Tyres coming from Canada, each one with approximately 15 tons of rubber from different parts of the OTR tire, sidewall, tread, and a mix from both. The operation had the final goal to evaluate both the yields and the product's quality. The process begins with loading the shredded rubber from OTR-Tyres into the reactor. The maxi bags, with 1 ton each, are discharged on a hopper and transported by a conveyor belt to a screw that feeds the reactor. The normal process is designed to load the reactor directly from the downsizing plant towards the thermolysis plant. After finishing the loading process and before starting the heating process, the reactor is closed and inertized using nitrogen. The heat to carry out the thermolysis process is produced by burning the syngas that is generated in the same process in a combustion chamber that can burn syngas and also liquid fuel if necessary. Both fuels are produced and stocked from previous batches. The reactor design enables a homogeneous distribution of the material and a high heat transfer efficiency inside the reactor, reducing the fuel consumption and therefore the emissions. Other environmental advantages of our thermolysis process compared to traditional pyrolysis processes are the lower operational temperatures and an adequate temperature control, which reduces the formation of nitrogen oxides and carbon monoxide in the flue exhaust gases. All these process features make it possible to achieve high standards of environmental quality. In order to verify this during the operation, all atmosphere emissions were measured by Eurocontrol, an accredited external laboratory from Spain. The heated gas produced in the combustion chamber is impulsed by a fan towards the external heating jacket of the reactor to begin the thermolysis. During the process, shredded rubber degradation is carried out. As a result, the generated hydrocarbon gases pass to an expansion tank and then to the heat exchangers, where a part is condensed. The liquid fraction is similar to a traditional liquid fuel, while the gas fraction, called syngas, is a mixture of hydrogen, methane, ethane, propane, and butane. The liquid fraction goes under a post-treatment process. It passes through a decantation tank to remove the water and a filtering process for impurities. Then, the liquid fuel is stored and ready to be sold. The fuel quality during this trial was characterized by SGS, a specialist laboratory. The gas fraction is purified from sulfur compounds and is used in the thermolysis process as fuel. The emissions from the syngas combustion are very low, reaching high environmental standards. Rubber coming from OTR-Tyres rubber has a mix of natural and synthetic rubber, being around 50% natural rubber. Therefore, these fuels, syngas and liquid fuel, have a fraction of biofuel, hence neutral in CO2 emissions. The solid product that remains in the reactor after thermolysis is recovered carbon black, known as RCB according to its ASTM terminology. This product is treated into the reactor before being discharged to clean it from the remaining hydrocarbons. Once the RCB is discharged, it's led to a milling system, and then to a granulation system, and then finally packed. After all these steps, RCB reaches a commercial quality and can be used in rubber products and plastic pigments manufacturing, reaching the circular economy within these industries. And most important, this helps to reduce the carbon footprint by more than 80% compared to traditional carbon black production. In our facility's laboratory, routine quality controls are carried out to verify the quality of each batch. Now, our technician is carrying out a routine analysis on an RCB sample using the ASTM1618 method, transmittance of toluene extract. The RCB obtained from this process was characterized by a specialized laboratory in carbon black and rubber compounds. Ecotr, with Novagas's thermolysis technology, achieves products with commercial quality: steel, syngas, liquid fuel, and RCB from EOL OTR-Tyres that enhance sustainable development of the mining industry and reduce the carbon footprint.